In this video, we're going to talk about fitting linear models to data. We're going to talk about scatter plots, the line of best fit, distinguish when it's linear and nonlinear, and then use a linear model to make predictions. So suppose we have this information, and we have, for a hamburger for this particular fast food, is 9 grams of fat and 260 calories. So this shows you like a grilled chicken light sandwich is 5 grams of fat and 300 calories. So we want to know whether or not it is a relationship between the fat grams and the total calories. We are not, however, trying to say that one causes the other. We're just seeing if there's some sort of relationship between the two. So if we graph it, it's going to look like this. So that's the data that I had up above on the fat grams versus the calories. And across the bottom here, these are the fat grams. And then of course in the y direction, I just want to remind you all this, one does not cause the other. In this direction, this is the calories. And we're looking to see is there some sort of relationship. Now it looks like it might be linear, so what we would do is we can do the line of best fit. One of the things we can do is we can just use a straight edge and eyeball it and see whether or not it works. And so let's take a look. If I just kind of eyeball it, let's do this. Let me see if this is going to work. So this looks like a pretty good line of best fit. That looks like a good eyeball. So that's a good line of best fit. And to me, it seems like a good line of best fit. Is it? Probably not the best line of best fit. The other thing I could do is I could pick 2 points. So I could pick, say, this point and this point, and then I could draw a line between those 2 points. So between those 2 points, that's my line of best fit. So I chose 2 points and did that line of best fit. Now, is that a better line? Maybe, maybe not. The other ways that we can figure out the line of best fit is actually with the calculations. Let me get rid of this. Nope. Nope, that's not what I want to do. No, that's not what I want to do. Let's try this again. I want to get rid of nope. I want to get rid of just that. Okay. I'll get rid of that line. And so we also want to get rid of this line. Okay. So the other way of finding the line of best fit is using this formula. You take all of your x values and all of your y values, you find the mean of them, which is the x bar, y bar, and then you do this summation, or you can just use technology, some sort of software, statistics, or a calculator. And the example that I had up above, my line of best fit using the software for statistics, we get this, where the 11.73 is our slope of the line of best fit, and this would be the estimated y-intercept, which of course we wouldn't truly have a y-intercept because it would make no sense. If you have 0 grams of fat, you're going to have 193 calories. So that's what that represents. So we use it, but it doesn't mean much in this representation because, 0 grams of fat, you still have calories. So once we do that, we can after we found our line of best fit, we can determine the calories if the menu contains 22 grams of fat. So we can take our example up here, or our line of best fit up here, which was y is equal to 11.73, and I put in the 22 calories and 193.89. Get my calculator out, and I can tell you that it will be 451.95 calories. Now, using that same line of best fit, if I would like to predict what the fat content would be, if I had 570 calories, then it would be 570 is equal to the 11.73x plus the 193.89. I go ahead and I subtract the 193 from both sides for 570 minus 193.89, and I get 376.11 equals 11.73x. I go ahead and divide both sides by 11.73. And so my predicted fat calories is 32 grams, not fat calories, fat grams, 32.77 grams of fat. And that's the predicted, remember they don't cause each other, but it is the predicted amount of fat if you had a 570 calorie item on the menu. So the correlation coefficients, the other thing we need to worry about. Correlation coefficient R shows you how close the data fits on being on the same line. The closer the absolute value of R is to 1, the better the fit. So in our example, our R was 0.9746. That means that our line of best fit is a good representation of the relationship between the fat calories, the fat grams, and the calories. If you had a line of an R value, a correlation coefficient, which will say negative 0.85, then the negative just tells us that our line of best fit is decreasing from left to right. It doesn't mean that it is worse than 0 in terms of correlation coefficient. And that's why we say here it is the absolute value of R. If we get a negative, it just means that the line is decreasing from left to right for our line of best fit. And that's it.